weren't. Behind the scenes, laboratories sprinted to decode the pathogen. Within 30 days of the first bovine sequence upload, 3 vaccine candidates entered pre-clinical trials in calves. Using viral-like particles and mRNA platforms, researchers aimed for broad-spectrum immunity that could block both avian and mammalian receptor variants. The challenge lay in economics. Poultry vaccines sell by the million for pennies, but immunizing every dairy cow would cost billions. Behind the scenes, laboratories sprinted to decode the pathogen. Within 30 days of the first bovine sequence upload, 3 vaccine candidates entered preclinical trials in calves. Using viral-like particles and mRNA platforms, researchers aimed for broad-spectrum immunity that could block both avian and mammalian receptor variants. The challenge lay in economics. Poultry vaccines sell by the million for pennies, but immunizing every dairy cow would cost billions. Parallel efforts explored antiviral feed additives, nasal probiotics, and CRISPR-based gene drives in migratory birds, ideas that oscillate between visionary and unsettling. Regulatory agencies balanced urgency with caution, mindful that a misstep could seed new ecological dilemmas. Yet collaboration blossomed. Geneticists in Kyoto shared structural models with immunologists in Ontario via open-source repositories, compressing discovery timelines. Field studies measured viral persistence in raw milk, finding infected particles survive up to 8 hours at refrigeration temperature, but perish within 15 seconds during standard pasteurization. This data fortified public messages that dairy remains safe, though risk perception rarely bends instantly to charts. Perhaps the most quietly heroic work happened in extension offices, where specialists taught farmers to build disinfectant footbaths, adjust airflow, and establish animal quarantine pens. Success stories multiplied. Farms that implemented rigorous entry protocols saw secondary infection rates plummet by 80%. These victories seldom make the evening news, but they tip the balance from inevitability to control. Science shines brightest when translated into daily practice. Each incremental improvement, a redesigned sanitizer nozzle, a faster PCR cycle, a crowdsourced genomic dashboard, builds the invisible levee holding back the storm. Yet no levee endures forever without collective maintenance. The ingenuity race extended beyond vaccines. Engineers in Finland trialed a rapid aerosol disinfection system for enclosed barns, utilizing hydrogen peroxide mist deployed by autonomous drones. Preliminary results showed a 98% reduction in airborne viral particles after a 3-minute cycle. Elsewhere, data scientists developed machine learning algorithms that listen to barn acoustics. Subtle changes in cow coughing patterns predicted infection 2 days before clinical signs, providing precious lead time for isolation measures. Universities partnered with indigenous knowledge holders to integrate traditional land stewardship practices, rotational grazing, diversified pastures, wetlands restoration, to reduce wildlife-livestock interface. These ecological interventions, often sidelined in high-tech conversations, demonstrated measurable decreases in wild bird congregation near feedlots. The message was clear. High-tech and deep tradition are not adversaries, but complementary pillars in a resilient biosecurity architecture. Public interest in these breakthroughs generated unprecedented crowdfunding campaigns. A global platform raised $10 million in a week to subsidize diagnostic kits for low-income farms, democratizing access to early detection. It was a vivid reminder that science thrives when citizens invest not only attention, but tangible support. Birds, cows, people, three classes of vertebrates sharing one viral breath. The H5N1 dairy outbreak is a parable of interconnectedness. Climate-driven migration shifts birds into new flight corridors. Agricultural systems place different species elbow to elbow. Smartphones stitch humans into instant networks of information. True or misleading, every boundary we draw, microbes rewrite in aerosols.